And the roll is being taken right now. Now, normally I don't take roll, but because of the beginning of the class here, I need to take roll to see who's in the class and who's not. Okay, so let's jump over to Canvas. Okay, so this is our Canvas class, and that is me in my tie-dyed lab coat that you'll see me whenever we start to go on campus. Now, this class is sort of divided up into two portions because we have almost 3 weeks of remote, and then theoretically we're going to be starting in class. Oh gosh. Now that may be extended. Many people think that's probably going to happen, maybe another week or so being remote. But anyway, at the moment, we are going to be starting in person either the week of the 31st or the next week. Okay, so I've got a lozenge in my mouth, so I apologize for that noise you hear. All right, a couple things. This is a pretty standard Canvas setup. I have one assignment for you set up already, and that assignment is to sign your lab safety contract. You're going to be doing it in person, in writing, and also electronically. And I give you 4 points for signing it. It's going to be the easiest 4 points you've ever earned in your entire life. Okay. I do a lot with modules, except in a lab-only environment. The modules are not as comprehensive. The modules are more comprehensive in a lecture environment. But because our class is going to be divided in the beginning into something called review modules, we're actually go ahead and review some of the earlier topics you should have already have in your grasp before coming into this class. We decided to spend some, because we're on remote, we decided to spend some time reviewing those for you. I'm going to start on that a little bit today, not a lot. The reason why our class today is going to be kind of short is because of Dr. Adkins' Monday class is not meeting to yesterday because of the holiday. So I don't want to get too far ahead of that other group. Okay, so normally I do everything in modules, and the problem with the review section in modules is it's mostly going to be a lecture and worksheets. And so it's hard to put all the worksheets under modules because I have a whole bunch of worksheets. We're going to be talking about dimensional analysis first. We'll be starting into that today. And you can see I've got a fair number of worksheets here. So I couldn't include all those in the modules. So for the review process, we're going to be mostly working from files as opposed to modules. Okay, if anyone's kind of confused or anything about what I'm saying, or it's hard to hear because of my lozenge in my mouth, just jump up. No problem. If you can't hear me clearly, probably other people can as well. So don't be shy about asking any questions. Okay, all right. So this is what it looks like. I have an admin section under files, and that'd be your syllabus, which I'm going to go over in a little while. The lab safety contract you'll see in a little while. The lab safety, or the lab lecture and lab schedule for Dr. Adkins in my class is here. And I've included Dr. Adkins' lecture schedule and exam schedule as well, since that'll be integrated into this class. And then I've also included the free OER textbook, which is a Libra textbook. And the origin of that is out of UC Davis, and I'm an alumni of UC Davis, so I always like to use their materials. The main thing is it's free for you. Instead of paying a couple $100 for textbook. This is a nice, pretty reasonable textbook, and it's free. So anyway, I downloaded it for you. You can also go to it directly and do it online totally. A lot of students like to have it in locally available for them, so they can cut and paste, take notes, etc. Okay, on the lab related stuff, we're going to see a whole series of labs once we get into the lab portion of this. And that's kind of an open moving target right now, depending on when we're coming back for the in-person part of this class. And again, most people feel it's going to be delayed by maybe a week or two, depending on how the peak. Right now, Sacramento and Yolo County is in the process of peaking, and the school will not allow online until that peak is passed. So that's what everyone's waiting on. That includes UCD, Sac State, and the local community colleges. Now, I'm also teaching out at Sierra, and Sierra is not doing remote. They chose to do online, or excuse me, they chose to do in person. So it's kind of interesting, the two dynamics. Okay. All right. So these are going to be the topics we're going to go over. Probably less so on pH, but definitely going to hit hard stoichiometry, hit hard on mole conversions, dimensional analysis. Those are going to be the real strong areas we're going to be reviewing, because that's the areas where students tell me they like the most practice with. But I have worksheets on all of these topics together. You just click on, for example, stoichiometry. You can see it's quite a bit of materials available for you. Quite a few. Okay. Now, I'm going to go over the syllabus. Now, this syllabus is combined from Dr. Adkins' syllabus. You'll see a lot of very similar verbiage in here. Now, the one thing I wanted to show you is, let me back up for a second here. Notice I've got a 1.00, 2.0. Those are the revision numbers. So if you see that number changing to 2.01, for example, that means the lab safety contract has been revised, and download your copy of it. And I'll have the revision number right up here. So you'll always know what revision number we're working from. Same with the lecture. Now, the lecture schedule is going to change, I would imagine, based on the remote status. Because right now, we're starting on wet chemistry, that 4th week, possibly the 3rd week. But right now, this is Dr. Atkins' schedule, which included our schedule here, because we have to integrate everything together. But basically, we've got, we're coming into the 4th week as a very classical series of wet labs for you. You're also going to be taking exams in lab. And you can see those lab exams there are 3 of them plus the final. And those are going to be taken again in lab. So I'll be basically proctoring those exams for your lecture portion. Okay, let's see here. Are there any questions so far? Okay, so let's jump back into the syllabus. Now, the syllabus always has got contact information. So this would be my contact information. Most students contact me via Canvas messaging, which goes directly to my Outlook. When I answer in Outlook, it goes back to your messaging. You can also get a hold of me directly in Outlook if you'd like. Both processes work fine. If you contact me regarding a question on a lab or a question on some review worksheets, please include a scan of the problem itself. What I'll do is we can either do a Zoom session or I can just respond via email. But the important thing is don't say worksheet number 12, problem 2. Scan it, take a screenshot of that problem so I know exactly what you're working on. Okay, so here's contact information. It's in terms of office hours, it's going to be noon on Tuesday or noon on Thursday, either one of those days, or we can set up a set. Most students, we end up making just an appointment rather than showing up on that particular time. That way it's more personal and we can usually cover more material that way. Okay, as you know from Dr. Atkins' meetings that you will have or already had, her lectures are asynchronous, meaning that there are no meeting times. She will record a video and you'll watch it at your leisure. My meetings are a modified asynchronous, meaning that I will post a time when I'm going to talk about whatever, and you're free to join me, or because I record everything, or you're not going to be there. It's totally optional for you. I would recommend attending as many meetings as possible, but I will not be taking roll, particularly during the review. Now, labs are required. You have no choice. You got to go to the labs. But as far as any review sessions in these next few weeks, they're optional. Now, some of you are coming into Chem 400 with a really solid background, and you may not need this review, and other people may be weak in certain areas in the review. Hopefully, we'll solidify that understanding. Now, Chem 400 is a combination of lecture and lab. The lab, this is a lab class, and you've got to pass both the you've got to pass both the lab portion and the lecture portion, period. No exceptions. So the lab portion is what we're doing with me. And the lab portion tends to be, there's two kinds of points in this class. There are hard points and easy points. Hard points come from exams or tests. Those are the hardest points you can get. The easier points to get are from participation and lab write-ups. So my strategy suggestion to you is to get as many of the easy points as possible. Those being the lab and participation points, because those are equal to test points. So you don't want to lose out on any of those. Okay, Chem 400 is designed for science majors, engineering majors. They're not, this class is not designed for allied health, which includes nursing, X-ray tech, etc. This class is designed for science majors, including pre-med, pre-dent, pre-pharm. Also engineering. Now, engineering students may not need a full year of chemistry, depending on what discipline they're going into in engineering. For example, civil engineering, mechanical engineering only needs 1 semester. It depends on your program. Sometimes it needs 2, a full year, but sometimes it's only partial. Where the other disciplines need a full year, biology students, chemistry students, pre-dentistry, pre-medicine, pre-pharmacy. Okay, the learning outcomes are typically what we're going to learn in here. You will, by the end of the course, will be schooled in all of these topics here and assess. Okay, because of good old COVID, this class is going to be partially in person and partially online. We already mentioned that before. And we'll be using Canvas extensively in here. I do everything with Zoom in terms of remote. If I create a video to be posted, I'll do it in Zoom. Even though I have no attendees, I'll still create the video within Zoom, just so that everything is consistent. Okay, there are some prior knowledge assumptions for students coming into this class. And Dr. Atkins has gone into this probably in a lot more detail, but basically we're assuming you know certain things. The problem comes in this high school chemistry. I taught high school also for quite a number of years. High school programs vary horrendously. They vary from just almost nothing to a very, very solid 1 or 2 year program. So it just varies all over the place. So for you to say, oh, I've had a year of high school chemistry may or may not prepare you for this class. Hopefully the review portion will. If you have an accommodation, make sure you contact me. Obviously, you will need to have internet access. And you also need a computer with a microphone, so you can have a webcam session, such as Zoom. Here are this is the LibreText. That's the one I downloaded for you. And there are other books you can get as well. Now, as far as the lab's concerned, you will have to get goggles, no exceptions. And they have to be a splash-proof goggle. That means it has indirect venting, or you'll read splash-proof. These typically run in the $11 to $14 range, depending on whether you're paying shipping or tax. I recommend that you get your own pair of goggles. We will have loaner goggles there, possibly. The department was talking about, because of COVID, not having loaner goggles, just because of the ease of transmission. But I recommend, for your own sanitary reasons, to get your own set of goggles. Now, you can either carry those in a pack, or you can keep them in your locker when we start the wet chemistry portion of the class. Okay, there is a lab manual available at the bookstore. It's fairly inexpensive. Basically, it's all the labs are developed in-house at Sac City, and because of that, all we have is printing costs. And then I usually recommend some kind of notebook to allow you to take notes or whatever when we're actually in the lab. But that's totally optional. You can do the classical black and white composition book, but there's a quad ruled, which is easier because you can do graphs more easily that way. Okay. Announcements are available on Canvas. Depending on the time of the class, etc., there may be a lot of announcements or very few. It just depends. I frequently will message the class as opposed to using announcements, just because that way I know the message goes out as opposed to assuming you're going to look on Canvas on the announcement. So I usually use Messenger for announcements. If you email me, I will try to get back within 1 day. I'm on my, I live by myself, only me and my dogs. You can hear them barking in the background. And I usually get back to you fairly fast. If you don't hear from me in 1 day, please email me again. You can also text me as well. And I don't have my texting number available on here. I don't know why. This is my texting number here. Feel free to text me if you want to set up an appointment, for example, or you can email me if you want to set up an appointment for office hours or anything like that. Okay, so that's the syllabus. Any questions about the syllabus? It's a pretty standard syllabus. There shouldn't be any real questions. What I want to do is go over how we're going to be graded in this class. Now, when we get into in-person labs, you're going to be required to do all the labs. If you miss 2 labs, you will automatically get a D, and that assumes you've done well in lecture. If you've done poorly in lecture, you'll get an F. And again, it's very important on labs. If you miss a lab, you need to get back with me as soon as you can and explain the circumstances, etc. Because of COVID, I have some techniques where we can make up labs, etc. Normally, if it wasn't a COVID situation, missing a lab is a big deal. Okay. I will have everything on calendar once we establish when we get back to in-person. The only quiz you're going to have in here in the short term is on the safety video you're going to be looking at on the 3rd week. It's American Chemical Society safety video. Now, when we get into the wet lab portion, those are 4-hour chunks. And normally we don't go all the way to 4 hours. Usually you can finish sooner, but I've allocated a 4-hour portion, and you're being credited with a 4-hour in terms of credits. But and then there will be formal labs. I'm going to go over those in probably week 3, how the write-ups are going to be. And they're usually due, not usually, they will be due a week after the lab. And then if you're late, there's a subsequent penalty here. Okay. Let's see here. Grading. Now, the lab portion of your total grade for Chem 400 is 15% of the total points. So I'm going to be submitting to Dr. Atkins 15%. That's if you got full credit on everything, down to zero, theoretically 0%. Okay. Now, every time you do a lab write-up, you will get 10 raw points. At the end of the semester, I'm going to tally up all the raw points and convert to a percent. So if you get 100% of all the points in lab, I'm going to convert that down to 15%. And that's going to be then submitted to Dr. Atkins, and she's going to put that into your overall grade based on your grading criteria from her class. Okay, does that make sense? So I'm going to be responsible for 15% of your total points in this class. And again, these are going to be mostly lab write-up points. Lab write-ups, you'll see in about 3 weeks when we go over them, aren't that hard. There's just a lot of work, depending on what lab we're talking about. But it's not hard. I want to stress that. It's not hard. It's just a lot of work. And they're easier points than test points. So you want to maximize those easy points. Okay, and this is from her class. You'll have 3 tests plus a final, homework, discussion. And here's where we come in right here. 15% of your grade is the labs. Okay. All right, you're going to be submitting your lab write-ups. I'll talk about this when we do them, but basically you're going to be converting them to a PDF file and then submitting them to me on Canvas. Okay. Now regarding writing up the labs, etc., you're going to be doing that in Word. So I will give you a Word template to use. And everything you'll be using for the lab, including the pre-lab questions, post-lab questions, procedures, purpose, conclusions, etc. All that will go into the lab write-up. And then you'll convert that to a PDF file. Okay, cheating and copying, you know, that's an ongoing challenge in higher ed, but I'm real picky on that. So please do not encourage me to get picky with you. Okay. It's really important. There's a lot to this class, really a lot. In the beginning, there's an assumption that you already know chemistry material coming into this. That's the purpose of why I'm going to be reviewing quite a bit of material. But there's an assumption that you've already had some chemistry, as I mentioned earlier. So it's very important to not get behind. If you get behind because there's a lot of material being presented, you're going to have all the material that you got behind on, plus all the new stuff. So it's very easy to get behind in this class. So I'm telling you right up front, don't. Stay on top of it as much as you can. You're all adults. It's easy to have a couple extra beers at night and say, oh, I can do it tomorrow. Wow. Do your studying before you have your beers. I've been a student. I understand that big time. Okay. The textbook is quite good. Dr. Atkins will be talking to you in detail about the textbook, where they are, etc. I believe you're starting on chapter 3 in the textbook. It's very important to take notes. When you take your notes, I want you to immediately, when everything is done, is to redo your notes. When you redo your notes as quickly as possible from the lecture or the lab lecture, the material is all is as fresh in your mind as possible. You also can clear up anything that doesn't make any sense in your notes. Sometimes you're taking notes, you're writing really fast, and you don't include enough information so that later when you're reviewing your notes need to make sense. So I suggest recopying your notes as soon as you're done. So you're going to end up with 2 sets of notes, the original set and your nice, neat, recopied one. It's also a nice way to review what you've done. You're going to have a combination of notes and re-notes, as well as, for my class, you're going to be looking at all the review notes on the material you're covering in the first 3 weeks, and also the worksheets. There's a lot of stuff for you to both review and when you get into the new material to work from there also. Okay. All right. Now this class has a whole bunch of problems. I'm not exaggerating at all. A whole bunch. You saw all those worksheets I showed you. And some of the worksheets have like 3 problems on them that are pretty involved, and other ones may have 20 on it. So it varies a lot. Those are the worksheets I've used over the last 18 years of teaching higher ed. And and all of them have answers in it, and the answers have setups as well. So there's no guessing as to if you missed the answer, you should be able to figure out why you didn't get the correct answer. Okay, but again, there are a whole bunch of problems in this class. And most of them you would class as word problems. Everyone loves word problems. So the thing I'm going to be stressed during the review is the strategy of how to work these problems. In other words, what are you starting with and what are you trying to do? You know, and then how do you go from the beginning to the end of the problem? So we're going to go over that strategy every single time. Now, Dr. Atkins probably has a similar strategy. So you can choose which strategy works best for you. There's a good chance that her strategy and mine are extremely similar, but probably not exactly the same. Okay. And these are Dr. Atkins' notes, practice, practice, practice. I can't emphasize that enough. Okay, let's see. As a student at Sac City, you've got a lot of resources available to you. You can submit a support ticket if something's not going right in Canvas, for example, or whatever. So there are technical resources available for you. Okay, any questions so far? Okay. This is a little deal on how to create a PDF. You can do it via your phone. You can do it via your tablet. The best way to do it, because they must be readable, the best way to do it is to use a page scanner. And a lot of printers come with a built-in scanner. So if your printer has a scanner built in, use that as opposed to your phone on creating the PDFs. These are some scanning apps you can get for your phone. I usually, let's see, which one am I using? I think I use Scanner Pro. I'm not sure which one. I have to look. But basically, they're all very similar. They all work pretty well, except you have lighting issues whenever you use your phone. You have shadows, etc., where the flatbed scanner doesn't have any of that. Okay, you're going to be submitting your PDFs to me as a PDF, not as a doc file, not as a JPEG, but as a PDF. If you submit it as a PDF, I can easily grade it. If you submit it as a bunch of JPEGs, I'm going to ask you to resubmit it as a PDF. Okay. These are some screenshots from Dr. Atkins' syllabus that I included. This is how you're going to be submitting your PDFs through Canvas. This is some background on me. Basically, my dad was in the Air Force, so we moved around a lot. I was born in 1950, so that tells you how old I am. And by the way, I had a birthday yesterday. But basically, I moved around. My elementary and junior high years were, every year it was at a new school. I had asthma when I was young, extremely bad. So I had a very challenging upbringing. And my father, though, retired in 1964 in Sacramento on McClellan Air Force Base. And I went to Foothill High School, and I was a typical high school student, active in sports and general social life. Nothing really big deal. However, I highly disliked science. when I was in high school. My science classes were awful. During the 60s, we were trying to play catch up with Russia. Russia put a lot of space-related stuff up in the air, and we were trying to play catch up. So they decided to have a huge re-education of America's students, and they created something called Inquiry Learning Science, which I hated in high school, just hated it. I ended up having great math classes, so I became a math major when I entered American River College. And then I transferred to Davis from there, and having, interestingly at Davis, I had great chemistry classes and lousy math classes. I shouldn't say lousy, maybe average ones. And as I got into upper division math, I hated abstract math. It made absolutely no sense to me whatsoever. I liked applied math. So anyway, I ended up changing my major over to chemistry and biochemistry, and because I liked it so much better than math. And I ended up going on to get a master's degree, et cetera. I enjoy teaching a lot. I've worked in industry and I've worked in education, and education won out big time. So that's a little about me. I'm one of the few vets on campus teaching in the faculty role. I was a Vietnam vet. And during 68 to 69, I was an avionics technician. In fact, I started before the term avionics was even invented. My specialty was autopilots and inertial navigation systems. Okay, the bottom line is you need to get turned on to a subject in class. And when you do, things get easier for you because you have a real interest, and that really helps you fulfilling your career desire. Okay, so that's basically the syllabus. Are there any questions about the syllabus? And this is revision 1.00. If I revise it at all, it'll be 1.01. Okay. All right. Again, this is the lecture lab schedule, and you can see where in our lab, you're going to be taking exams where I'll be proctoring them for Dr. Atkins. And you'll have 3 of those plus the final. And again, this is going to be revised based upon week 3 and 4. These guys here. And that'll be probably the end of next week. We'll probably know more on that. But for right now, this is the tentative schedule. Okay. Okay, let's see. But the main thing when we get into the review in a second here, we're going to be working off files. And that's where your worksheet practices are going to come from. And for example, under dimension analysis, just just standard all stuff, And this is typical dimensional analysis, meaning you're just converting one thing to another, converting days to minutes. Density problem here, you're converting volume, a gallon, over to mass. But the bottom line is lots and lots and lots and lots of practice. And just stuff on scientific notation, significant figures, metric system conversions, just lots and lots of conversions. And again, each one of these problems, I'm going to be showing you a strategy how to work them. Okay, so I've covered sort of the administrative aspect of the class in terms of the syllabus, lab lecture schedule. You're going to have a lab safety contract to sign once we are in person, and that's what this looks like. You're going to be submitting this on paper and electronically. Okay, so any questions so far? I'm going to do some review stuff now. It's not going to be long, however, because I don't want to mess up Dr. Atkins' schedule since Monday was a holiday. Everyone's comfortable how to get a hold of me. Okay, you guys are awfully shy today. All right. I'm looking through some of the questions here. Okay, I'm looking at Solomon's question here. Are the files already published and where should we get them? Okay, I just showed you where they're published. And we'll do an intense review on nomenclature. That's part of the review topics I have. The lab manual you won't need until we start wet lab. And those are all questions that I can answer. Okay. All right. Well, let's go ahead and start on the review process. Okay. Now I use OneNote, Microsoft's OneNote extensively, and that's what this is. Okay. So when we are remote, these are the things we're going to be doing. We're going to be taking roll, which I'm doing right now. On week 3, you're going to be doing a lab check-in, lab safety. There's going to be a safety quiz, the contract I just showed you, and we're going to be doing topics review. When we finally get into lab in person, you're going to be doing a classic set of wet labs that have been around, I swear, for 150 years. They're very classic labs. And also you'll be doing testing from lecture in there as well. Okay, so when we get into reviewing, these are the topics we're going to be covering. We'll be covering dimensional analysis, mole conversions, stoichiometry, naming, molarity. And these are the topics that most students need the most review on. Now, some of you don't need any review. I had some students from my Chem 300 class that were excellent students, and then if they're taking our Chem 400, they don't need to review anything. Other students really struggled, and they really will benefit from the review process. Okay. Gosh, excuse me. I hate this. It's so frustrating. I have continual COVID tests, which have been all negative. I've had all my vaccinations and boosters. I'm all caught up. Basically, either stomach acid related, the cough, or allergy. And most likely it's allergy. Up in Washington, I took allergy injections and it fixed the cough totally. So I'm gonna put another lozenge in my mouth and I'm sorry if it makes my speech not as crystal clear as it can be. All right, so first thing we're going to be doing is dimensional analysis, and there are kind of three parts to that. I'm going to show you the process. There's some strategies how to work it, and something called significant figures, which come into process anytime we do any kind of math related stuff. We always have to consider significant figures. Okay, so let's talk about all right, so let me give you a typical problem. Oh, something like how many seconds are in a month? Okay, so all problems in this class can go through certain steps. First step is if there is a reaction, balance the chemical reaction. Okay, now in this case, there's no reaction at all. So number one, we can skip. Step number two, what is given? Step number three is what is to be calculated. Step four is the setup. How to go from given to the calculated answer. Okay. Now this will go through all the stuff we're doing in review. Whether we're talking about mole conversions, we're talking about stoichiometry, we're talking about molarity, all that stuff. 4 steps, period. Okay. Now, step number one is there a reaction? No. So we can skip that step. Okay. What is given? Well, for everyday month. What is to be calculated? Seconds. Okay. Now the setup. Now the setup involves conversion factors. Well, so whenever we start with a given, that is going to go on the left. What are to be calculated is going to go on the right. And the setup is going to get us from left to right. Given to calculated. And those are via conversion factors. Now, conversion factors. Fractions. You always have 2 versions of the factors. Inverses. So as an example, how many seconds are in a minute? Well, we know that 60 seconds are in 1 minute. But we also have the inverse of that. Always, you always have two conversion factors. The question is, which one are you going to use? Which one are you going to use? Okay, so we have 30 days. That's given, that goes on the left. Seconds on the right. Now, back once. And let's stick with these colors. Okay, so how do we go from days to seconds via conversion factors? Well, what conversion factors do we know? Well, we know that there's 30 seconds in a minute. There are 60 minutes to an hour. $24 hours to a day. Okay. So how do we go from days to second via conversion factors? Well, is there a conversion factor that has both days and seconds in it? No. We've got days down here, seconds up here. So that means it's going to be a multi-step problem because the conversion factor does not have both the given and calculated in it. Okay. Conversion factor is going to have both the given and calculated in it for it to be one step. Okay, so that means we have to go through some intermediate steps. Which ones are we going to use? Well, it looks like because seconds go to minutes, that would be a first step. And then once we have minutes, we can go to hours. Once we have hours, we can go to days. Okay, so days to hours, that's an intermediate step. So we have 24 hours per day, or 1 day is 24 hours. Okay, for this to happen, we are going to have our days cancel as far as units goes. That means days are on the bottom. We have 24 hours in 1 day. So now we have hours. We don't have days anymore because we use the conversion factor to go from days to hours. Okay. We don't want hours, we want seconds. Well, we can't go directly from hours to seconds. We have to go through minutes. Okay. We want the hours to cancel. So now we're down to minutes. And we can go from minutes to seconds directly. Same process. Okay. Now, how do you know this is set up right? Well, one, notice when we canceled the units, all the units cancel except for seconds. And that's what we're trying to calculate. So that means our setup is right. Now, if you were taking me as lecture as well, and I gave you this problem, that's worth 90% of the points. It's the setup, not your answer. Your answer is 10%. Now that shows you how much importance I place on setup. Now to do this problem, take out your handy dandy calculator. I'm using a TI-84. There are many calculators out there that work fine. The department does not like you to be using a graphing calculator for this class. You need to check with Dr. Atkins which are the appropriate calculators to use. Okay, so what we're going to do is remote. Now, the way I teach students to do this, I tell everyone to multiply everything on the top, hit the divide key for everything on the bottom. Well, everything on the bottom is a 1, so you don't have to worry about that. So basically, we're going to be going 30 times 24 times 60 times 60. Our handy dandy calculator gave us okay. Now, if we express that as scientific notation, it would be okay. So that's an official process for every single dimensional analysis problem we'll be doing. Now, this happens to be a 3-step problem. And the only reason it's not a 1-step problem is because the conversion factors do not have days and seconds in it. And you have to, so we'll have to have a multi-step process to get there. Okay. Now, does anyone have any questions about this process? There should be at least one question for what I just did.
I have a question.
Yeah, Cameron, yeah.
Do you usually want us to write our answers like the full number or in scientific notation?
Either is fine. I'm going to talk about scientific notation as a separate topic. The purpose of scientific notation is to make an awkward number less awkward.
Mm-hmm.
So 259,200 is kind of bordering on awkward. To me, it wouldn't matter. Sometimes you get a number with 23 zeros after it. That's considered an awkward number. So definitely scientific notation. That's going to depend on what Dr. Atkins wants you to do. Okay? Because that's going to be kind of built into a test question. Okay. Any other questions? There should be one question you should be asking me based on your previous background coming into this class. Precision. Okay. These are all exact by definition. 30 seconds is exactly, by definition, equal to 1 minute. That means that is infinite precision or infinite significant figures. All of these are by definition. 30 days, it was just an arbitrary thing. So this number here is the least precise of all the numbers. So it determines precision or significant figures. Now, question is, how many? How many sig figs does the number 30 have?
Is it
Oh.
unknown?
That's a good answer. Why do you say unknown?
Because after, when there's no decimal, it's continuous. I think that's what it's called.
Yeah, sometimes they'll say, instead of unknown, they'll say undetermined, but unknown is fine. Yeah, exactly. The problem is we don't know if 30 is exactly 30, or is it 29 or 31? We don't know. So depending on whose class you're taking, in what school and what department, and whether it's math class or chemistry class, it's either undetermined or one significant figure. Now, one way around that is to convert this to scientific notation. This will tell you how precise 30 is if you convert it to scientific notation. This here says it's one significant figure. Up here, it's two significant figures. Okay, so let's talk about significant figures now. Now, I stress the term measured. So significant figures determines the precision of the measured number, not the number by definition, like 30 seconds to a minute. It's only if it's measured by an instrument or by your eyeball. Okay. Now, a measured number would be something like you're reading a volume off of a graduated cylinder. You're measuring something with a scale. You're measuring something with a telescope or something, you know. You're using some kind of an instrument, including your eyes, to find a number. That means there needs to be some kind of precision built into that number. If it's by definition, then the precision is infinite because it's by definition. It's a perfect number. 60 seconds is exactly equal to 1 minute. So that would have infinite significant figures, infinite precision. Okay, well, what if it's not by definition? There's one other exception, and that is something like counting. Okay, so if I go, that's 3 counts. Is that 2.9 counts? Is that 3.1 count? No, it's exactly 3 counts. Okay, so that would also have infinite significant figures. Everything else is measured, and everything else will have some kind of precision built into the number. So let's look at a whole bunch of numbers and determine the precision of those numbers, or the significant figures of those numbers. Secondly, there are rules of significant figures in terms of the process we're going through. Now, this is what I want to cover today. And then on next week, we're going to get into dimensional analysis using significant figures. And then we're going to get into some of the molarity things, and then some of the stoichiometry things as the weeks progress. Okay. Okay, so I have a number and how many sig figs. Now the question is, how can I practice the stuff I'm talking about today? You will go to Canvas and go down to dimensional analysis under files. And here are all the dimensional analysis worksheets, including significant figures. I have a number of activities on that, also scientific notation, etc. Okay, so that's where you'd go to practice what we're talking about today. Okay, so let's look at some numbers. Okay, so here's a bunch of numbers with their associated significant figures. Now these, of course, remember, are these measured again. Okay, so we just have a series of numbers, 1, 2, 3. Just count them, and that's how many sig figs it is. If there's a decimal point in there with no zeros, same thing, you just count them. Now notice here, we have 0.0041 that has 2 significant figures. Okay. 410, two significant figures. 410 decimal point, three significant figures. 1.001, four significant figures. 1.02 times 10 to the third, three significant figures, excuse me. 1000, one significant figure. 0.30, two significant figures, and 0.0004, one significant figure. Okay, so if we were just looking at plain old numbers, it's straightforward. You just count them, and that's how many sig figs it is. Zeros mess things up. So we have to have some rules regarding the zeros. And there are three situations with zeros. Okay, so okay, if the zero is at the beginning, it's never is at the beginning, it's never significant. For example, 0.30, 0.00004, never significant. In the middle, always significant. Are we having fun yet? I hate this guy. Okay, if it's in the middle, we have 1.001. That means those zeros count because it's in the middle. That means that number has four sig figs. Let's see, that's the only one with zeros in the middle. But basically, zeros in the beginning never count. Zeros in the middle always count. And then the question is, at the end. Okay, so there's two situations. If we have a decimal point, they count. Oops. No decimal point. They do not count. Okay. So the zeros, three situations in the beginning, in the end, and in the middle. The first two are very straightforward. Okay. If they're in the beginning, they never count. In the middle, they always count. And if there's a decimal point present anywhere in the number, they count. If there's no decimal point, the zeros at the end don't count. Oh, sorry again. Okay, so okay, this would have 2, 3 sig figs. because that decimal point is present, we have to count the 0 as being significant. No decimal point, we count that as not significant and we don't count it, or it's undetermined if you're in certain classes or particularly in math class. Okay, but as far as our lab is concerned, we are going to say, instead of saying undetermined, we're going to say it has 2 significant figures. Now, the person that asked me that question, does that make sense? I forgot who asked me that question regarding sig figs. Okay, so one other thing. So when we are doing operations, there is multiplication, division, operations, and addition, subtraction operations. Okay. Okay, when we're adding and subtracting, you look at the number of decimal places and take the least. So if we're okay, what's the answer to that? Well, it's okay. So we take the least number of decimal places. So the answer to that is 13.2. Okay. Because this is the least. 13.2. Okay. When we are doing multiplication division, then the answer is the least precise number. Okay, so let's say 36 times 3.12. I don't know what the answer is. According to your calculator, it's okay. So is that the right answer? Okay. You have to analyze significant figures. Now, this is a multiplication division problem. So we're going to take our answer is going to have the least number of sig figs based on what we're multiplying or dividing. So this has 2 sig figs. This is 3 sig figs. So our answer is going to have 2 sig figs. Okay. Now, this number at the bottom, 112.32, has 5 sig figs. So that is not the correct answer using precision calculations. Okay. What we have to do is convert that 5 sig fig into a 2 sig fig number. Okay. To do that, we go to the third place and round from there. Okay. 0 to 4, we drop it. 5 or more, we increase. Okay. And this is going to affect the second place. All right, since that's 0 to 4, we're going to drop it. So our answer is one of two answers, okay? It's either going to be that or that. Now, the problem is, if we look at 11 versus 112 or 110 versus 112, which is closer to 112? Well, the 110 is. This number is extremely far off and doesn't make any sense. 110, though, does. 110 is close to 112, okay? And because there's a 0 at the end with no decimal point, that means this has 2 sig figs. So our answer is 110. Okay, let's divide 314 by 1546. Okay. So this would have 3 sig figs. This would have 4 sig figs. So our answer is going to have 3 sig figs. Okay, when we divide it, let's see what the calculator tells us it is. Okay, 314 divided by 1546 is a big, long number, okay? So this number, 0 doesn't count. So we have 0 in the middle counts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sig figs. So now we have to convert that 10 sig fig number to a 3 sig fig number. So what we're going to do is we're going to go to the fourth significant place. 0 doesn't, the preceding 0 doesn't count. That means we're looking at this here, 1. The 1 is 0 to 4, so that means it just dropped. So our answer is going to be 203. 3 significant figures. Now your calculator will frequently do this to you. It'll give you zillions and zillions of places and all that junk. It's superfluous information because the precision doesn't warrant it. Our precision says we need 3 sig figs. So that means our answer is 203. Now, that middle 0 is significant. Beginning 0 is not significant. So that's why that is 3 sig figs. Okay, so that's what I wanted to cover today. And again, I want to remind you that under files, under dimensional analysis, I've given you lots of practice. And every single one of these uses significant figures. Every single one. You'll be doing that in Dr. Atkins' class for the rest of the semester and in my class the rest of the semester. And any future science or engineering class you're going to take, you're also going to be considering significant figures. Your beginning physics class that some of you are going to take or already have taken, they do dimensional analysis just like this class. Engineering classes, same thing. So whenever we're working in the world of numbers that are measured, we always have to consider the precision of those numbers. That precision comes in terms of significant figures. Okay, and remember I am recording this. I'll post this. Okay, so any questions we've done so far?
I had one.
Yeah.
So for the multiplication example you gave us, we used 3 decimal points because the bottom figure had 3 significant figures. Is that correct?
This guy?
Yes. So we went 1, 1, 2, and we used 2 because 3.12 had 3 significant figures.
I'm not sure I follow that last thing you said. one of, the 36 is 2 sig figs, right?
Mhm.
3.12 is 3 sig figs. That means our answer is got to be 2 sig figs. But right now, this 112.32 is 5 sig figs. We need to convert that to 2 sig figs. We go to the third significant place, which is the 2 here. That's 0 to 4, so we just drop it. But we have to make sure we put a 0 there as a placeholder, because if we don't, we end up with 11.
Okay. Mhm.
And 11 is really not anything close to 112. But 110, using 0 as a placeholder, is close.
Mhm.
And because the 0 has got no decimal point on there, that means the 0 doesn't count. That makes that 2 sig figs. Is that where you're going with that?
Yes, and
Yeah.
then the same thing for the division part of it.
Exactly.
Thank you.
And then when you add and subtract, you just look at decimal places. This is 1 decimal place, 2 decimal places. So your answer is going to have 1 decimal place, and you just round the same way.
Thank you.
You're welcome. Okay, you guys have any other questions?